Okay, all right. Thanks to the organizers for sending me the invitation and also introducing me. And I'm Tailin. I'm a PhD student at the CTU in Prague. And my research interests are catchment hydrology and hydrological modeling. Today, I'm really glad to be here at this GIS day to give a presentation about GIS application in the field surveys for investigating soil moisture patterns. So first, I'll just briefly go through the outline of today's presentation. First, I will tell you why we are trying to investigate the soil moisture patterns, and then where is our research area, where we are trying to do the field surveys, and how we're going to monitor the soil moisture in the field. And later on, I will tell you what to do before and after the field surveys, and in the end, I'll give you some take-home messages. First, the motivation, why we're trying to, to investigate the soil moisture. Just think about when you're standing in the piece of land, like on the picture, like the picture on the right side. Are you seeing the runoff generated? There's some overland flow in the picture. You will think about where you may come up with some questions about where's the water coming from, and how is water or how is the runoff generated? How is the water connected? So to answer this kind of question, soil moisture really playing an important role, and because the flow really connect easily when in the wet part of the catchment. And in the agricultural catchments, as we all know, the soil moisture is really high. It's highly dynamic because of some agricultural activities, such as tillage practice, also sometimes irrigation. Therefore, we would like to understand the soil moisture patterns in the agricultural catchments. We want to know which part of the catchment is much drier, and which part of the catchment is much wetter, and what's the dominant factors that cause this kind of special patterns. So now I will just take you a tour to the Czech countryside, to our study area where we did all the experiments. So first of all, our catchment, it's called Niučice. It's the name based on the Czech village nearby. And our catchment is it's relatively small. It's about half square kilometers. And it's near Prague, about 1 hour by car, as you can see on the map here. Here are some basic informations about our catchment. The elevation is about 400 meters above sea level, and the climate belongs to humid continental. As you can see, more than 90% of the land covered by farmland we are used for agriculture. And then the catchment divide into 3 different fields, as you can see here, 1, 2, 3 fields. And the catchment is only joined by one stream here in the middle of the catchment. And then I will show you some pictures of our study area to give you a better image of our catchment. This one, it's as you can see, so the landscape in our catchment, you can see really homogeneous land management patterns here. I would say it's a typical agricultural landscape in the Czech Republic, even in the Central Europe. And then this picture, I would like to show you what kind of crops are growing in the field. I took this picture in the spring this year, and at that time they were rapeseed in the catchment. And this image I just want to show you as you can see, the water are just pounded in the wheel tracks. I just want to show you there are some human impacts, agricultural activities, which really influence the runoff generation. And now I will show you how we measure the soil moisture in our catchment. As you can see on the map here, we have the infrastructures at our catchment, and To measure the soil moisture, we have in situ point measurements which cover the catchment to the depth between 10 to 60 centimeters. And besides that, we also have portable TDR probes. We have one called HydroSense 2, which measures the soil moisture at topsoil about 12 centimeters. Besides that, we also use the cosmic rays neutron sensing method. Just briefly introduce this cosmic ray neutron sensing method. Basically, it's a neutron detector. It's trying to detect the near ground neutrons. Basically, the neutrons are, let's say, the cosmic rays are coming from space, and the neutrons are really sensitive to hydrogen. And near ground surface, the biggest hydrogen pool is it's in the soil water. So based on the neutron counts, we can convert the values to how much water, to the amount of water in the soil in the radius of 100 to 200 meters. We have two static CRNS probes in the catchment, as you can see on the upper part of the field, and there's another one in the string. The orange area is the measurement range of these static probes. There's also another one called CRNS backpack. Basically, it's a portable CRNS sensor. You can just move it around with a backpack. And here are the two pictures, just to give you a better image. How does the sensor look like? This one are the CRNS backpack I mentioned before. Basically, you just leave it into the ground, leave it for 20 to 30 minutes, and then it gives you a neutron count. And based on the neutron count, you can convert it to the soil moisture, soil water content. And the second one here on this image, it's HydroSense sensors. Basically, it measures, as mentioned before, it measures the sensors of in the topsoil of 12 centimeters, and in each point, you just insert it into the ground, and it gives you a value of soil moisture content. And at the same time, to record the GPS location. And today, I will just mainly focus on the portable HydroSense sensor and also the portable CRNS sensor for the field surveys. And now I will tell you what to do before the field surveys. Let's say before the field surveys, we always have a question. Let's say where to make the measurements. Before answering the question, I may come up another question for you guys. Let's say we say there's map from the survey we did in 2019 in October. Each point represented the HydroSense survey we did. And do you think it's a good survey or a bad survey? You have 2 seconds to think about it. And in my point of view, I think I wouldn't say it's a bad survey, but I would say it's not so efficient, because here we have more than 1,000 measurement points. It's really time consuming. If you divide the task by 2 people, it costs almost 1 day to finish the survey. And then, as you can see, the density of the sampling points are not so homogeneous. There are more sampling points and close to the road. And also in the upper field, the density is kind of is quite dense, but then in the lower part of the field, the density is really low of the sampling point. And also the coverage of the measurements. As you can see, there are many sampling points are really out of the catchment boundaries, which is useless for the future analysis. And also sometimes we say there's some sampling point, there's some area of the catchment we didn't cover it with our sampling points. So back to the question, where to make the measurements? And it's easy to say it on the map that we do measurement here and there, but then we are in the field. Sometimes we just get lost because it's really hard to find the benchmark, to benchmark points, to see the boundaries and to see where you did the measurement. So to do so, we would like to know, when we're in the field, we would like to know where we are and where are the boundaries. So there are, currently I'm using two softwares or two applications. First one is Google Earth. I think most of people, they know about it. Here is just as you can see, the interface of the Google Earth. I just I have the catchment, the yellow part is catchment boundaries, and here's the string of the catchment, and the red circles are the CINS backpack, the measurement range of the CINS backpack. Basically, during the field surveys, I was trying to go to the center of the red circles and place the backpack there, and then move to move to another point after one measurement, after each measurement. And then this one for the picture down there, you see several points. They are the sampling points for the hydrosense surveys. As you can see, the sampling points distributed more homogeneously, and then it's more efficient, and in total it's more about 200 to 300 points. And then we can divide the task. If we divide the task by 2 people, we can finish even just by half a day. And also the results are easy to interpret in the future. And basically, if you're in the field, you just download the Google Earth application before go there, and try to have the project placed in your phone, and then you can turn off your data, and then turn on your GPS, please. And then there's another application called QField, which I have attached the link here in case you don't know, you are not familiar with it. Basically, it's an application that you can import your QGIS project to your mobile phone, and it's open source, first of all, and then second, you can use it offline, which is really useful when you're in the field. And it's the same method as Google Earth. You just turn on your GPS, you know where the location where you do the sampling. Here I'm showing you the sampling points of the hydrosense 2. The spacing between each sampling points is it's about 40 meters. And so after this field surveys, you need to interpret your results. Otherwise, the result you get is just like the points, because you need to think about how to get from the point data, get the spatial patterns. So that's why we need GIS statistic analysis. So to do the GIS statistic analysis, there are many methods to do that. You have here I just list 4 of them: the QGIS, Julia script, and also Python script, and there's another one called ArcGIS Pro. And the first 3 are open source data. It's completely free and well documented. ArcGIS is not open source. It's ArcGIS Pro, it's not open source, but it's also well documented. And here I will just go through the details. So for QGIS, you just go to the toolbox and try to type the interpolation, and then you will find the several interpolation methods, such as collision here, or inverse distant weighting interpolation, or tin interpolation. And here I'll just show you an example I did for 5 field surveys. And I used the ordinary collision method here. And as you can see, on these 5 different field surveys, we observed some similar spatial patterns of soil moisture. For example, here, there are some dry spots in the upper part of the catchment. And here there's also some in the middle of catchment close to the stream. it's relatively wet. Of the soil is relatively wet. And for Julia scripting, Julia, it's a high-level programming language. It's just like Python. And if you're not familiar with it, I attached the link here. It's there's a library called geostats, which gives you some functions to interpret the result. And here I just attached the diagram I tried to fit for different field surveys. And then for Python, I think many of you are familiar with Python language. There's the one I'm using. It's called PyCrigi. The library I'm using is called PyCrigi. And basically here I just show you the two interpolation I used. I use the same input data from the same sampling day, but then I just tried different parameters to fit the diagram model. And as you can see, we get different interpolation result. And then I will show you the ArcGIS-Pro. ArcGIS-Pro, the main disadvantage I mentioned before, it's not open source, so it's not free. But then it's really well documented. If you have any doubts or some questions, you can always find fun explanations on their documentations. And to do the geostatistical analysis, there is a function called geostatistical wizard. And inside of the geostatistical wizard, there are many. You can see there are many interpolation methods, such as kriging and inverse distance weighting, as mentioned before, and so on. Here are some examples for the interpolation for the kriging interpolation. First, what we need to do is try to fit the semi-variogram model. So you can say try to optimize the model here. There's a function to optimize the model automatically. And here you could select a different models such as exponential or Gaussian or stable. There are several options you can choose. After that, you can it can give you a cross validation of your model, and it gives you the goodness of fit of the model you're trying to fit. And then in the end, you will get the based on the semi-variogram, you get the interpolated map like this. Here I'll just show you two interpolated map from two field surveys. So based on the two spatial patterns we have here, we could say first of all, the soil moisture, it's quite heterogeneous, and even though when we have a quite homogeneous land use patterns in our landscape. And then second is like we find some similar soil moisture patterns, such as the dry spot here, as you see, and some wet areas in the middle of the catchment. And last is just some take-home messages I give you. First is you need to have a good plan before you go to the field surveys, and to make it more efficient. Otherwise, you waste a lot of time and then couldn't get the results you wanted. And second, there are many ways to interpolate the field results. So therefore, choose the suitable one based on your research. If you ask me which one, because I listed 4 methods. If you ask me which one I would use for my research, I would say for detailed investigation for 1 or 2 field surveys, I would go for ArcGIS-Pro. But if I'm trying to analyze some statistical sensors for a long time series, which have tons of data, I might use a scripting such as Python or Julia. And that's all from my side. I hope it will be useful for you. And thanks for your attention. If you are interested into our project, our catchment, you can scan the QR code or send me email. And that's all from my side.